Alright, Assalamualaikum. JIM 212 Statistical Methods. This is the e-lecture for second chapter chi-square test. There are four subtopic in this chapter, and the first part, okay, as introduction. Um, the chi-square distribution was used to find the confidence interval for variance or standard deviation, and you have learned this in elementary statistics. And the chi-square distribution also can be used to test a hypothesis about a single variance or standard deviation. Okay, this is your previous knowledge, what you have learned previously in elementary statistics. And for this course, okay, there are several more use of chi-square test. The first one is goodness of fit. Okay, we can use the chi-square distribution for a goodness of fit test. And as introduction, the chi-square test is used to test if a sample of data came from a population with a specific probability distribution. Another way of looking at that is to ask if the frequency distribution fit a specific pattern. Okay, two values are involved, and observation denoted by O sub I, which is the frequency of a category from a sample, and the expected frequency E, denoted by E sub I, which is calculated based upon the claim distribution. Okay, and expected is equal to n multiplied by the probability of x. Okay, for I 1, 2, 3 to k. The idea is that if the observed frequency is really close to the claim, okay, the claim means the expected frequency, then the square of the deviation will be small. Okay, this is logic. So the square of the deviation is divided by the expected frequency to wake frequency, and in this part, a degree of importance lah. Okay. Um, if the sum of this weighted squared deviation is small, the observed frequency are close to the expected frequency, and there will be no reason to reject the claim that it came from that distribution. Only when the sum is large is the reason to question the distribution. So therefore, the chi-square goodness of fit is always a right tail test. Okay, the distribution is skewed to the right, so the chi-square goodness of fit test is always a right tail test. Alright, so this is the chi-square test for hypothesis. H0, the data follow a specified probability distribution, and H1, the data do not follow the specified probability distribution. And the test statistics is O minus E square divided by expected. Okay, O E, actually this is the sum of, okay, uh, this will be the sum of uh, observed minus expected square divide by expected, and follow the chi-square distribution with k minus 1 degree of freedom. And what is k? K is the number of category, O sub I is the observed frequency, and E is the expected frequency. Okay, so this is the test statistic for goodness of fit test using chi-square. This is one tail test. Okay, and the chi-square test, chi-square distribution is skewed to the right, and by using alpha, you need two important point here to find the critical value chi-square alpha and k minus 1, where k is the number of category, and this is the rejection area. Okay, we reject H0 if the test statistics in this area, and of course do not reject H0 if the test statistic between 0 to the critical value. Okay. Properties of the good news of fit test. Okay, the data are the observed frequencies. This means that there is only one data value for each category. Okay, the degree of freedom is one less the number of the category k minus 1. Okay, not less than the sample size. It is always a right tail test. It has a chi-square distribution, and the value of the test statistic doesn't change if the order of categories is switched. Okay, so there's no problem to switch the order of category because the value of test statistic doesn't change. Okay, we look for the first example. Suppose a market analyst wish to see whether consumers have any preference among 5 flavors of a new fruit soda. A sample of 100 people provided this data. Okay, which flavor they prefer? Cherry 32 consumer, 28 choose strawberry, 16 choose orange, 14 choose lime, and 10 choose grape. And the question now is, do consumer show any preference for flavors of the fruit soda? Okay, so first step, what we have to do is we have to state the hypothesis H0 and H1. So H0 is the consumer show no preference. Okay, so consumer show no preference for flavors of the fruit soda. And the alternative hypothesis is the consumer show a preference. Okay. All right. So this is the first step. We have to state the null hypothesis and also the um, alternative hypothesis. So second step, you can find the critical value, or you can find the test statistics. Okay, either one. Okay, let's say I try to find the test statistics. Okay, test statistic chi-square is equal to the sum of observed minus expected square divided by expected. Okay, so in this case we have the observed value. This is from the original data, so this is the observed. So what is the expected value in this for this data? Okay, so if consumer uh, show no preference or for flavors of the fruit soda, that means the distribution uh, choosing this flavor should be uniform. That means from 100 sample, 20 will choose cherry, 20 will choose strawberry, 20 consumer will choose orange, 20 will choose lime, and 20 will choose grape. That means there's no preference. Okay, so all the consumers show uh, um, almost the same choosing preference. Okay, choosing the flavor. Okay, that means the expected value for this data is 20. That means 20 choose cherry, 20 choose strawberry, 20 choose orange, 20 choose lime, and 20 choose grape. That means there's no preference. Okay, so now we can calculate the test statistics for the first flavor, cherry. So the observed is 32 minus the expected is 20 square, then divide by 20 plus, okay, the sum of. So the second category, strawberry, 28 minus 20 square, divide by 20 plus the third category, 16 minus 20 square, divide by 20. The fourth category, 14 minus 20 square, divide by 20. And for the last category, grape, 10 minus 20 square, divide by 20. Okay, now you just have to simplify and use calculator. So the answer is 18. Okay, so this is our test statistic 18. So now we have to compare with the critical value to decide either we can reject H naught or we fail to reject H naught. So in this case, the critical value from the chi-square distribution table, you have to refer to chi-square alpha k minus 1. Okay, k minus 1. So k is the number of category. So for this set of data, we have 5 category: cherry, strawberry, orange, lime, and grape. So k minus 1 is 4, and alpha is 0.05. Okay, the standard alpha in statistics. So now if chi-square 0.05, k minus 1 is 4. So refer your table, chi distribution table, chi-square distribution table. So the answer is 9.488. Okay, 9.488. Okay. This is the critical value. Okay, so from the graph, chi-square distribution skewed to the right. This is the critical value, 9.488. And this is the critical region, and we will reject H naught if the test statistic in this region. Okay, now the test statistic is 18. So 18 is somewhere here, 18. That means the test statistic is in the critical region. Then we have to reject H naught. Okay, we have to reject H naught. So now we have to reject H naught. So that means H naught rejected. Then we have to accept H1. That means consumer show a preference. And then you have to summarize the result. We know this is the result, that consumer show a preference. So you have to write the conclusion, okay, the summary. So there is enough evidence to reject H naught. That means the consumer show we have to reject H naught, right? So we reject H naught. That means show a preference. Okay, show a preference for flavor of the fruit soda. Okay, so we have 1, 2, 3, 4 and 5 steps. Okay, 4 or 5 steps. So the first step, you have to state the hypothesis, null hypothesis, and alternative hypothesis. Second step, you can start with calculate the test statistic, or you can start with find the critical value, either one. So the next step, if you the second step you calculate the test statistics, then the third step you have to find the critical value. The fourth step, you have to compare the value of test statistics and critical value before we can proceed with the last step to make a conclusion, okay, or summary. Okay, one more example. The advisor of an ecology club at a large college believe that the group consists of 10 freshmen, 20% of sophomores, 40% juniors, and 30% seniors. The membership for the club this year consisted of 14 freshmen, 19 sophomores, 51 juniors, and 16 seniors. Okay, so this is the observe. Okay, this is the observe value. Okay, this is the observe value. And what is the predicted value? So the predicted value is what the advisor believe. So he believe should be 10% of the total number is freshmen. He believe 20% from the total number of group is sophomores, 40% are juniors, and 30% are seniors. So this is what he expect, and actually this is what he observe. Alright, so at alpha 0.10, test the advisor conjecture. Okay, first step, you have to I think it's better for us to state all the expected and the observed value. So actually for freshmen, the observed is 14, the expected is 10%. So from the total student is how many students here? 14, 51, 70, 100. Okay, from 100 students, so 10% from 100 is 10. So this is what he expect. For sophomores, he expect 20%. So 20% from 100 is 20. So this is what the advisor expect. And for junior, he expect 40%. So 40% from 100 is 40. So this is what he expect. And 30% is senior. So 30% of 100 is 30. This is what he expect for senior. Okay, now we have all these values. We can proceed with the first step. You have to state the null hypothesis and the alternative hypothesis. So the null hypothesis, the club advisors, actually you can state the club consists of 10% freshmen, 20% sophomores, 40% juniors, and 30% seniors. And what is the alternative? The distribution is not the same as stated in the null hypothesis lah. Okay, so the distribution is not the same as stated in H0. Okay, so this is the hypothesis. So second step, we can calculate the chi-square test statistics. So the sum of observed minus expected square divided by expected. Okay, now we have four categories. The first category is freshmen, the second category is sophomores, the third category is junior, and the last category is senior. So for the first category, freshmen, observed is 14 minus expected is 10 square divided by expected is 10 plus for second category, sophomores, observed is 19, expected is 20 square divided by 20. The next is juniors. Observed is 51, expected is 40 square divide by 40. And the last one is for seniors, expected is 16. Observed is 16, expected is 30, square divide by 30. Okay, now you just have to simplify and use your calculator to find the test statistics for this. So the answer is 11.208. Okay, so this is the first step, this is your second step, and the third step you have to find the critical value. Okay, you can find the critical value from the chi-square distribution table. You just have to know the alpha and also the degree of freedom. So in this question, we have to refer to the chi-square. Alpha, the degree of freedom is k minus 1. That means alpha now is 0.10. And the degree of freedom is a k minus 1, the number of category minus 1. Now we have 4 categories, so minus 1 is 3. Okay, so from the table, with alpha 0.10 and the k is 3, the critical value is 6.251. 6.251. Okay, so from the curve, this is somewhere here 6.251. This is the critical region that we have to reject H naught if the test statistic fall in this area. Now the test statistic is 11.208. So it's fall in this area, 11.208. That means we have to reject H naught. Okay, we have to reject H naught. So when we reject H naught, you have to state the conclusion. So reject H naught. So the distribution is not the same as stated in the H naught. So as a summary, there is enough evidence to reject the advisor claim. Okay, okay, that means the distribution is not like what the advisor claim. Okay, so that is the first part. Okay, the first part, the use of the chi-square distribution or chi-square test. Okay, there are three more subtopic, three more tests that we can use the chi-square distribution. Okay,